For the start of this lecture, we're going to do some precipitation reaction practice. If you find you need to, please review lecture 28.3, which will describe how to write net precipitation reactions. We're going to look at precipitation reactions and write net equations, and there is a slight plot twist at the end. Here is our first question. Identify the net precipitation reaction that occurs, if any, when the solutions below are mixed. I've given you the names of the compounds in the two solutions, and it's up to you to translate the names to the ions and then determine what precipitates in a balanced reaction. You might want to have the precipitation rules in front of you while you do this exercise. And now a short video that will at least answer for you if E is correct.
In this series of experiments, we're going to take two separate solutions and mix them together and see what happens. On the left, we have iron 3 chloride, and on the right, we have sodium hydroxide. Clearly, a precipitate formed with that mixture.
Your next combination is potassium iodide and lead 2 nitrate. Once again, a short video.
On the left is potassium iodide, and on the right is lead 2 nitrate.
How about sodium acetate and ammonium chloride? Of course, please pause and think about the answer before proceeding to the reaction part of the video.
On the left is sodium acetate, and on the right is ammonium chloride.
Strontium nitrate and copper 2 sulfate.
On the left is strontium nitrate, and on the right is copper 2 sulfate. And there it goes.
Cobalt 2 chloride and sodium phosphate.
On the left is cobalt 2 chloride, and on the right is sodium phosphate.
Sodium acetate and silver nitrate. Once you've chosen an answer, let's watch the video.
On the left is sodium acetate, and on the right is silver nitrate.
Now you see that there are two correct answers to this question that I will accept. For most of the situations, we used concentrations that were 0.1 molar. This was at the end of the day's filming, and we wanted one more example, so we grabbed some reagents off the shelf that were higher concentration. We took more concentrated solutions than the previous examples, and what we found was, oh, a precipitate does form. So when we looked up the KSP of the two items, sodium nitrate and silver acetate, we found that the KSP of silver acetate is 1.9 times 10 to the minus 3. When you do the calculation, you realize that silver's solubility in water with acetate is 0.044 molar. Well, we were at 1 molar. I guess you can see why a precipitate occurred now. Please don't worry that there will be any tricky questions in your homework or in your tests. I wanted to show this example to highlight that our solubility rules are just general guidelines, and for true solubility, you need to look at KSP, which means you need to take Chemistry 201.